Even though we have already talked about the mixer, I think it would be worth the while to repeat all the insert and return, so the serial and parallel processing we can achieve in a digital audio workstation. Now, as far as the mixer goes, anywhere in a digital audio workstation or in real life, the mixer is a device that's going to be summing or mixing, as the name implies, mixing several audio signals into one. But aside of being a summing device that is going to join tracks into one track, it can also divide one track so that we have a copy of it sent somewhere else. So each one of these sends is actually sending a copy of a track where we engage it, sending a copy of that track into one of the return tracks. We have 4 of those, hence we have the 4 sends, meaning that this track is sending to the return track B. It's this one, with a reverb on it. So if I enable this reverb on that track, it means that this is going to be an act of parallel processing, as in we have the original sound right here going into the group track, and then the group track goes into the master, and then we hear it, but a copy of that is sent right here, and that copy, being processed by the reverb, is also sent to the master, so they are in the end all joined together, but we are processing a copy of this track right there, and hence this is parallel processing. Now we have a reverb on that channel, and let's hear what that sounds like. Let me just see where this track actually has anything to play. So it's this loop. So you can see as I send more of that track, so as I send a higher gain of this track into the return track where the reverb is, I get more reverb. Since the reverb becomes louder, the signal I'm sending to the reverb to make reverb out of becomes louder. So let's hear only that signal, only the reverb happening right here. I'm guessing that a lot of other things out of this project are also sent there, so we can hear everything that is sent to this reverb to produce reverb for. Of course, because I pulled the volume up on this loop a lot, this is the main thing that we can hear. If I pull it down back to where it actually was, at minus 24. The reverb here is created for a lot of the things here that were sent to this B return track using the send. So all of these tracks that send their copy to the B return are processed by this reverb. So it only spits out the wet portion of the sound, only the reverberation that is added onto those originals, so that I can in fact use that one reverb to add reverb for any of the tracks right here. So each one of the tracks that is actually sending its copy to this reverb is having that reverb added by this unit right here, because it makes reverb out of anything it receives. So if I send all of those elements, and you can see that I'm sending those in uneven manner, so I don't have to send a lot at the same amount of volume of this track and this track. I can send less of this, meaning that the reverb for this track is going to be quieter. So the more I send, the louder the signal and that copy of this original is that is being sent to the return track. Hence I get a louder reverb for that track, and also by that extent that track has more reverb, so it sounds like it's further away in the soundstage. Now this is the parallel processing, and we went through that first because it is more complex than inserts, and inserts is just a serial process, meaning that our signal, as it goes from, let's say, this run, right, this one, as it goes from this track into output group, this group, and that group goes into its output, which is the master, and then the master goes into our speakers. In that pathway of this signal, I'm going to be inserting plugins. I'm going to be inserting processing units. Right here I have the LFO tool first, and then right after that it goes into the group. Then on the group we have no processing, and then that group goes into the master. Then we have this processing on the master, meaning that all of these sounds are going to be affecting that one sound, going through all of those stages. So an insert process is the one that is inserted into the pathway of the signal as it goes through the mixer towards the master track, which we are going to be hearing in the end. Of course, serial processes are processed in serial, meaning that if I place another process right after this one will be applied first, and then the resulting signal out of that process is sent to the EQ, then it's, let's say, filtered by the EQ, then I can add an overdrive, so the resulting signal that's coming out of the EQ is sent to the overdrive, and so on and so forth, meaning that this going into the overdrive, then into the EQ, is probably not going to sound exactly the same. Now, that fact is there is going to be a difference with different ordering of effects, just depends on the effects in question. So the whole difference between the insert processing or serial and the returns processing our signal, which is parallel processing, is that the inserts are in the path of the signal as it goes toward the master track, and it goes through them in series. So first through the LFO tool, then overdrive, then EQ, and so forth into the midliners group where we could have some effects that process it, then into the master where we do have some effects processing it, until it goes out into our sound card or audio interface, which sends it to our speakers and we hear it. And with the parallel, we still have that same thing happening, everything that I just told you, but we have a copy of that track or that signal going into this track, and there we process it with something else. So that means that we still have the original, but we're also processing a copy of that and adding that to the whole mix. Now, we usually use those sends for time delay based effects, but you could use them for anything in parallel. You could use it for parallel compression, parallel distortion, saturation, whatever you can think of. One thing to notice is that if plugin delay compensation doesn't really take care of the latency being introduced by the plugin you're using right here, you could have phasing problems if, let's say, parallel compression is in question. But not to worry about that. If you're actually using time delay based effects, you will make your life much easier, as you can add reverb by just sending tracks to the return tracks, which actually have processors on them. So when thinking about a process, any process that processes the signal and spits out something completely different without you ever hearing the original signal ever again. And that could be the distortion, the EQ, meaning that once the signal goes into distortion, it comes out distorted. If it goes into the EQ, it comes out filtered. If it goes into the compressor, it comes out compressed. But if we're thinking about a delay, a reverb, chorus, flanger, phaser, those effects, time delay based effects, actually comprise that effect they do from adding something to the original signal. So without the original signal, the effect doesn't really work. The delay doesn't really work without the original signal, without the original thing being delayed. The reverb also does not really work without the original sound to which we are adding the ambience. We are adding that reverb on top of it. This is why we usually use those kinds of effects on the return tracks. And I say usually because you can do whatever you want. Breaking the rules is just one of the things that could guide you to maybe discovering something new.